For, centuries, the question, are we alone, was really just for philosophers and science fiction writers. But that's all changed. The search for life out there has gone through this huge transformation. It's moved from just an idea into a real, coordinated, full-on scientific mission. So let's follow the clues.
This quote from the great Carl Sagan it nails the spirit of this new age perfectly. We're moving past just believing, past just hoping. We're getting into the world of hard evidence and real data-driven science. The goal isn't to believe anymore, it's to know.
And why now? Well, because for the first time ever, we've actually got the right tools for the job. We have these incredibly smart rovers crawling all over the surfaces of other worlds, and we have revolutionary telescopes like the James Webb pointed at the skies of distant planets. We are actively, right now, gathering clues.
Okay, so that really is the million-dollar question, isn't it? If you're going to be a cosmic detective, what clues are you even looking for? And I mean, in the massive, unbelievable vastness of space, where do you even start? The whole thing depends on knowing what to look for. The word scientists throw around is biosignature. And really, you can just think of it as cosmic fingerprinting. A biosignature is any piece of evidence. It could be a weird mineral, a specific gas in the air, a complex molecule that just shouldn't be there, unless life put it there. It's the smoking gun that separates cool geology from actual biology.
All right, so let's start our investigation right here at home, in our own cosmic backyard. Mars has always been the prime suspect for hosting ancient life. And just recently, the Perseverance rover stumbled onto one of the most exciting clues we have ever found.
And listen, that is not an exaggeration. When the head of science at NASA, Nikki Fox, says something like that, you know it's a huge deal. This thing has sent shockwaves of excitement through the scientific community, and it all boils down to one very strange-looking rock.
So here's the play-by-play. Back in July of 2024, Perseverance was driving along and spotted this rock, now nicknamed Chiava Falls. Fast forward to September of the next year, and after a whole lot of analysis, NASA makes the big announcement. But, and this is the absolute key, to be 100% sure, we need to get that rock back here on Earth. The Mars Sample Return mission is the final make-or-break step.
So if we zoom in on this sample, which they've called Sapphire Canyon, scientists saw these weird leopard spots, and inside those spots, they found two very specific minerals, vivianite and gragite. Now, here on our planet, these minerals are often the direct result of microbial life. They're basically the leftovers, the waste products that tiny organisms leave behind after they eat and breathe.
So, how would these ancient Martian microbes have even lived? Well, this analogy from the research team explains it perfectly. Life is all about harvesting energy. Just like water flowing downhill can power a mill, microbes can grab the energy that's released when one chemical turns into another. The theory is that Martian microbes were basically eating the rock, using iron in the process, and leaving behind those leopard spots as the fossilized evidence of their last meal.
But of course, good science means you have to be skeptical. So you gotta ask, could these spots have formed without life? Well, maybe. It's possible, but the non-biological explanations just don't fit the scene very well. For instance, to make that grigite mineral without life, you usually need really high temperatures, like over 150 degrees Celsius, and there's just no evidence this rock ever got anywhere near that hot. The biological story, it just fits the clues so much better.
Okay, so from the ancient, dusty past of Mars, our search now leaps way out into the outer solar system. We're looking for life that might be alive right now in a place that has zero sunlight, Jupiter's icy moon, Europa.
And the potential here it's just mind-boggling. Underneath that thick shell of ice, Europa has a salty liquid water ocean that holds twice. Let me say that again, twice the amount of water as all of Earth's oceans combined. If life needs water to get started, then Europa is one of the best bets in the entire solar system.
But wait, no sunlight. So how would anything get energy? Well, there's this really fascinating idea called radiolysis. The theory goes that these high-energy cosmic rays from deep space are constantly slamming into Europa's ice shell. When they hit the water molecules in the ocean below, they literally break them apart, releasing electrons. Just like plants here use photons from the sun, microbes on Europa could potentially be using these electrons as their power source. It's a way for life to exist in total, complete darkness.
And hey, this isn't just some far-off sci-fi dream. It's happening. The Europa Clipper mission is on its way. It launched in late 2024, and it's making that long, looping journey out to Jupiter right now.
By 2030, it's going to start a whole series of close flybys, using all its fancy instruments to sniff out the chemical ingredients for life and really figure out what's going on in that hidden ocean.
All right, buckle up, because now we're zooming out even further. We're going interstellar. Beyond our solar system, the James Webb Space Telescope is basically letting us eavesdrop on the atmospheres of exoplanets, searching for these incredibly faint chemical whispers that might hint at a living world light years from home.
Now, one of the most talked about targets is a world called K2-18b. And let's be clear, this thing is no Earth twin, not even close. It's way more massive, probably a world covered in a deep ocean with this thick, heavy, hydrogen-rich atmosphere. But what makes it so fascinating is that it's in the habitable zone, where temperatures might be just right for liquid water.
And this is where it gets really exciting. When JWST analyzed the atmosphere of K28b, it found this tantalizing hint of a gas called dimethyl sulfide, or DMS. Now, the reason that made front-page news is pretty simple. Here on Earth, as far as we know, DMS is only made by life, specifically little marine organisms like plankton. So finding it somewhere else, that would be an absolutely monumental discovery.
But, and you knew there was a but, right? We have to pump the brakes. The signal was very, very faint. In science speak, it only hit a 2.7 sigma confidence level. Now, to actually claim a discovery, the gold standard is 5 sigma. That means you are 99.9999% sure it's real and not just a fluke. So we're not there, not yet. It's a fascinating hint, but it's not a confirmation.
Even so, the very fact that we are having this debate is revolutionary. Like the researchers themselves said, we've basically entered a new scientific reality. For the first time in human history, we can actually analyze the air of alien worlds and have serious, data-backed arguments about whether there are biosignatures in them. It's incredible.
So all of this, it brings us to our final and maybe the most profound question of all. In every single one of these searches on Mars, Europa, and K2-18b, we're looking for a life that is, kind of like us. But what if we're being too narrow-minded? What if life follows a completely different blueprint?
There's a great term for this bias: carbon chauvinism. It's the assumption that just because life here is built on carbon and loves water, that all life everywhere has to play by the same rules. Now, it's a totally reasonable place to start, but it could also be a huge cosmic blind spot, causing us to look right past life that is truly, deeply alien.
Silicon is the most famous alternative to carbon. It's right below carbon on the periodic table, and it can also build complex molecules. But it's got some problems. Silicon bonds are weaker, and its waste product isn't a gas like our carbon dioxide. A silicon-based creature would basically exhale sand, which, isn't impossible, I guess, but it's definitely a challenge.
So where does all this leave us? Well, the path forward seems to be about 3 big shifts. First, for Mars, we have to go from analyzing stuff there to bringing it home to study in our best labs. Second, we have to develop agnostic ways to find life without just assuming it's like us. And finally, for the search for intelligence, we need to get smarter about how we listen, accounting for things like space weather that could be drowning out a signal.
And this leaves us with the ultimate challenge. As we stare out into the cosmos with all our amazing new tools and ideas, we have to keep asking ourselves this one simple question. Are we really searching for any kind of biology in all its weird and wonderful forms? Or are we just looking for a mirror? The answer to that is going to define this whole next chapter of exploration.